Assalamualaikum warahmatullahi wabarakatuh. My name is Fatin Farhana binti Mano. I am from group number 53. So today, me and my group mate would like to discuss about G4 experiment. For the experiment, we have three types of experiment, which is core logging, Schmidt-Rebound harness test, and for the last experiment is point load test. Okay, before that, I would like to introduce my fellow group mate, Muhammad Hafizi bin Ismail, Muhammad Haziq bin Abdalil, me myself, Fatih Fahana binti Makno, Nur Syairah binti Muhammad Noah, and lastly Nur Zamira Iliana binti Harun. This experiment was conducted on 27 August 2021. So for core logging interaction, I will explain a bit later. I will explain a bit. Sorry. Okay. For core logging, the sample recovered from borehole and excavation, we will from the sample recovered from borehole, we will know the characteristic of a rock which play a major role in determining its engineering properties and will need to be given due attention when describing the rock to know the strength, the weathering effect, and the discontinuities. So the discontinuities is the most significant of this, and so particular attention is to pay to this aspect. Engineering properties of rock are not included in and cannot be reliable inferred solely from this type of geological classification. Okay, the objective of this core logging experiment is to obtain physical description and RQD of rock cores recovered from borehole drilling. For the next discussion, I will let my friend to elaborate more. That's all from me. Thank you.
Okay. My name is Muhammad Haziq. So I will explain about the apparatus and rock sample for this testing. First, we need for apparatus. First, we need core barrel. Second, we need measuring tape. And then for the procedure for the test is state of the weathering. 2, core recovery, and 3, rock quality designation RQD. So I will pass to my team member to explain further.
Hello, my name is Muhammad Hafizi. So I would like to explain about the data for the G41 core logging. So we have two sample, core A and core B. So this is the distance between joint to joint. And then we need to calculate the CR recovery ratio and the RQD. So first we must calculate the core recovery CR, which is the length of core sample recovered divided by total length core. So for the core A is recovered 1.5 meter, so divided by 1.5 meter, we will get 100%. And then the second one is for the rock quality designation, which is the formula is the joints between distance to distance of the joints, which is the measurement more than 100. So we sum up and then we divide by the total length of core sample recovered. So we will get the value about 61.33%. So for the sample B, same as sample A. So that's all from me. I would like to pass to my another teammates. Thank you.
Assalamualaikum. My name is Nur Syairah binti Muhammad Noah, and I continue about discussion. Okay, for discussion for this experiment, for sample A, RQD value is 61.33%, which is the sample was fair in rock quality and moderate in pitted rock. This type rock has medium weathering. And for sample B, the RQD value is 79.33%, which is the sample was good in rock quality and consists of a good quality of hard rock. This type have less weathering. And for the conclusion, I pass to Zamira. Thank you.
Okay, for the conclusion, from this experiment, we can conclude that the experiment test the we can conclude that the sample B is a good one compared to sample A, because sample B got good quality in hard rock, and for the sample A is fair quality for hard rock.
Okay, for second experiment is ischemic rebound harness test. Okay, for the introduction, the ischemic hammer is perhaps the most frequently used index in rock mechanics practice for estimating the unaxial strength (UCS) and modulus of elasticity of intact rock. Okay, the device is portable and may be used both in the laboratory and the field. Okay, for the objective is to determine the hardness and unaxial compressive strength (UCS) of rock. Okay, for the apparatus and procedure, I will pass to Fatin Farhana. Thank you. Okay, so for the apparatus for Schmidt rebound harness test, for the experiment, we've used the Schmidt hammer type L with impact energy of 0.7 Newton meter. And the second one is sample cradle steel of minimum weight of 20 kg. Note that when sample cradle is used, hammer is vertically downwards. Okay, for procedure, we already discussed in our group on how to calibrate the Schmidt hammer. Okay, so the specimen obtained shall be studied after to know the best selection of rat sample and how to conduct the test and on how many samples should be tested. This already discussed and already described in our report. Okay, so for the rebound number R will be converted to surface compressive strength using several methods, and it will obtain our US value for every rock samples. For the next experiment, I will pass to my I will pass for the data. I will pass to Hafizi to elaborate more. Thank you.
Okay, for the data, so we have about 20 a number of rebound reading. So we must find the UCS value for all the rebound number from 1 to 20, and then we need to find the average number for the rebound and then the average for the UCS. So the method to find the UCS value is we must depends on this graph. So let's say we have rebound number 40, and then we find the intersection between this line, and then we get the estimated value of the UCS. So for this data is about 50, and then we total up, and then we find the average rebound number and the UCS average. So next I will pass to my teammates. Thank you.
Okay, for the discussion we get from this test, for this experiment, the average number of rebound is 40 and the average UCS is 52 MPa. From the chart B, the density of rock is 20.5 kilonewton per meter cube, and the average dispersion of strength is plus minus 30 MPa. Conclude that the rock is classified as strong because it's located 50 to 140 MPa. The rock type may be consist of two some low grade metapod marble and some strongly cemented sedimentary rock, some weathered and metameric igneous rock. For the conclusion, I will pass to Zamira.
Okay, for the conclusion, from this experiment, we can conclude that the objective of this experiment was met, because for in this experiment we need to determine the harness and unaxial compressive strength that we call UCS, and the parameter is important to classify the the parameter is important that we can classify the type of the rock, so we can know that the rock is more stronger or not stronger.
Okay, for the last one experiment is point load test. Okay, the introduction about point load test is carried out on core rock specimens or irregular rock fragments to obtain the point load strength index IS50 and unconfined compressive strength. Depending on the specimen, three types of tests can be performed: diametral, axial, and irregular lump. Okay, testing procedure are suggested by ISRM 2007. Okay, for the objective is to determine the compressive strength of rock specimen from irregular lump test. Okay, for the procedure, I would like to pass to my friends Zamira.
Okay, for the procedure, firstly we need to discuss we actually discuss with our group member about the characteristic of the irregular lump test. So from that we can determine how many tests should be conduct for a site and why we should be conduct. And third step, we need to discuss how to conduct the test. Fourth, include the mode of failure or invalid test. So next, we need to present calculation that involve to obtain the incorrect point load strength. The lastly, present a complete report with your writing. So we need to do some research about how we need to do the test, and we need to do a report. Okay, next.
Next, for the data, so we have three given data, and then we need to calculate area DE square, IS, F, IS50, and then we get the UCS. So for the first one, we must calculate the area. Let's say we take the first data as a sample, so we get 962.11. Then we calculate the DE square, so about 1225 mm square, and then we calculate the IS, which is P over DE square, so we get 9.49 MPa. And then we calculate the F, which is D divided by 50 power of 0.45, so we get about 0.852. And then we calculate the IS50, which is the formula is IS times F, so we get about 8.09 MPa. And the last one, we get the UCS by multiply the IS with the 24. And then we need to do it for the another two sample. So that's all. Thank you.
Okay, for discussion, as you can see, the value of UCFs for sample 1, 2, and 3 were obtained. From the result, we can see that sample 2 has higher value of UCS compared to sample 1 and number 3. From this experiment, we can see that the diameter and the width of the weight will affect the strength of compression, which is if the diameter is big, the value of the diameter is big and the weight is also big, the US value will be higher. So from this test, there are few modes of failure, which are valid diametroid test, valid axial test, and valid block test, invalid core test, and also invalid axial test. So for the characteristic for irregular lump test as follows. So you can see there is a length width diagram over here. So conclusion, I will pass to Muhammad Aziz. Thank you.
Okay, the conclusion we can get from this testing is the objective of this experiment is to determine the compressive strength of the rock specimen. So when we conduct this test, the specimen, the strength of the specimen was meet. We for the test we meet the objective for the test. Thank you. That's all from us.